Guys, today we will discuss one program which is related to circular convolution using FFT and IFFT. In the previous video we have discussed the problem which is related to solve the circular convolution using FFT and IFFT method. Okay, so here we'll see one program, okay, that is related to circular convolution. Using Matlab, we will write one program and we will execute, we will run that program. Okay, we will discuss each syntax one by one. Okay, then we will understand this program. This program mainly important in the exam point of view. This program will ask in your DTSP lab or DSP lab. Okay, just understand the program and write the program easily. Okay, first we will see the simple thing. Okay, what is the CLC? Okay, CLC is a clear command. So if we are that command, this is a command window. Okay, this is the command window, this is the current folder, which means whatever we have saved the programs previously, that file name will get displayed in this current folder section. Okay, and this is the editor section. In this section we can write the program and we can execute the program very easily. Usually we will prefer to write the program in the editor section and command window section. In this command window, this is the command window section. In this window we can execute each syntax individually and we can see the result, but usually we won't prefer this execution of program in the command window. We will prefer to write the program and execution program in the editor window. This is the workspace window. Okay, in this window we will see whatever variables we have used in the program, right? Those variables will display in the workspace. Okay, and thereafter, see here, what is this CLC? CLC means is a clear command. What is this clear command? So what is this clear command? What it will do? So for example, if you are writing some syntax or some executing the syntax in the command window. So see here, I am writing here x is equal to 6, y is equal to 4, right? Z is equal to x plus y, right? The result is 10, right? See here. So this is the execution of execution using the command window. So we are writing the individual syntax and we are executing in the command window. Okay, so I have to clear this command, so we have to use CLC. See, I have used x, y, z variable, right? So I have assigned the x value as a 6, y value as a 4 and z value is we have performed the addition operation, the value is 10, right? See here in the workspace, so the x in the x variable x6 value is stored, in the y variable 4 value is stored, and in the z variable 10 value is stored. The result is stored. Now I am going to clear this workspace using a clear all. Okay, see here, just I will enter clear all in the command window. See, in the workspace nothing will be there. See here, see, everything is deleted, removed. Okay, by using a clear all. So close all means if we are opening some figures, right? If you are executing some or we are displaying some figures, That time, if you are using the close all syntax, it will close all the pop-up windows. It may be in graph windows or whatever it is. We will see. I will show you after a few minutes. Okay, so how it close all works. Okay, so now we will discuss the convolution, circular convolution using FFT and IFFT method. So by writing a program in the Matlab. Okay, so these three syntax is common to all the programs. Okay, CLC, clear all, close all. What is this dismiss? It will display. This is the program to perform circular convolution using FFT and IFFT method. It will display in the command window. Shall we see this output? See here, I will run. This is the we can use this triangular, right? It is rotated. Okay, this if we are clicking this run, right? So the program will run and we will get the output in the command window. Okay, so this syntax, it will display the whatever we have written in the single quote, right? So here we have written, this is the program to perform circular convolution using FFT IFFT. See here, this is the program to perform circular convolution using FFT IFFT. Thereafter, f printf. This, what is the use of f printf? So inside this function we have written backward slash n, right? So n, which means it gives one space after this. This is the program to perform circular convolution using FFT IFFT. So it will take another line, new line, right? New line. Here we are seeing enter the first sequence, right? So between this there is a one space. So in order to give space, we are using fprintf function. Within this function we have written backward slash n within the single quote. So this is very important. Writing the function in the correct format is very important. Okay, then so I have written x is equal to, x is the variable, you can take any variable. X is equal to input. It is a function to get or receive the input from the user. Okay, so we can enter the inputs if we are using this function input, right? Within the bracket we have written enter the first sequence colon. We have to enter the first sequence. It is entered by the user, by us. Okay, similarly h is equal to input. We have to enter the second sequence. We are performing the circular convolution, right? We need two input, the first input and second input, right? This input function, input within the common bracket we have written enter the second sequence, right? Within a single quote. So right, so we have to enter the second sequence. Okay, just I will show you, just I will enter the first sequence. Okay, so I will take, so whatever we have solved problem. Okay, so I have solved this problem and also I have discussed this problem in the previous video. Okay, see here I will take 0 1 0 minus 1. This sequence I will take for the x. 0 1, sorry, 0 space 1 space 0 space minus 1. See, so I am getting the second, right? I have to enter the second sequence, H sequence, right? This is the H sequence. See here, 1 2 4 8, right? 1 2 4 8, 1 space 2 space 4 space 8. Then you have to press enter button. Okay, we will discuss these things, okay, later. After that, So I need the length of x. So this is the user defined variable, right? This is a user defined variable. We can mention any variable. It is up to you. We can also use len without underscore x, okay? But this is this is an inbuilt function, right? Input of x, f print of this. These are the inbuilt functions, okay? Length of, so I need the length of this variable x. I need the length of this variable h. So I have to mention length of h. So thereafter what we did, see here, the same procedure we have to follow, right? So first we have to calculate the length of n. We have to find out the value of capital N using maximum of n1 comma n2. See here the same thing I have mentioned here. So in order to find out maximum of length of x and length of n, so we have to use this maximum function of x, max of x, okay? So we have to use this variable length underscore x and length underscore h. So that result is stored in the length of y, okay? So length of y. Thereafter, so I have to perform FFT operation, right? That is the second step. So I have to perform DFT of x1 of n, DFT of x2 of n. That is, I have to determine x1 of k and x2 of k. So that one here, so in order to find out DFT, here we are using FFT. What is FFT? Fast Fourier transform. It will give same output. Whatever we are getting in the DFT, the same output will obtain it from the FFT function, right? FFT of variable, whatever we have determined, FFT of x and its length x. I have to mention that FFT of x and length. So we have determined this maximum length we have to take, right? This length y, I have to length underscore y, I have to use that. So display. So I have displayed the DFT of x. See here, what is the DFT of x? See, this is the DFT of x. Shall we check it? Shall we check it here? DFT of x, whatever. What is the DFT of x? See, 0 minus j2 j2. 0 minus 2j, 0 plus 2j. See here, 0 minus 2j, 0 plus j2. So I am getting like this. It is a complex. It will display as a complex number. Okay. The next, how to find out the second sequence, FFT. Next, FFT. So this is the FFT of H, right? So I am displaying that FFT of H here. So shall we check it here? See what is the value h of 15 minus 3 plus j6. 15 minus 3 plus j6. The remaining 2 minus 5 minus 3 minus j6. Minus 3 minus 3 minus j6. Afterwards, I have to perform multiplication. After converting time domain to frequency domain using FFT, I have to perform convolution. I have to multiply. So in the frequency domain, we have to multiply these two sequence, x underscore FFT, h underscore FFT. So this is very important. Just we shouldn't use star mark. We have to use dot star. Okay, dot star in order to multiply two sequences. After multiplying, so we will get result this one, right? So 0 plus J6 plus 12, 0 minus J6 plus, shall we check whether we got the same answer here? See at 0, 12 plus J6, 0, 12 minus J6, we got the same answer. Thereafter, in order to get y of n, so we don't need y of k. In order to get y of n, so we have to convert frequency domain to time domain. We need IFFT, inverse fast Fourier transform. This is the output of FFT, right? So y underscore FFT, right? It is in frequency domain. This is length of y. So we are performing inverse fast Fourier transform and we are displaying. This function is the circular convolution output is here. The circular convolution output is the display function can be used to display whatever we have written inside the single quote. It will display in the command window. So the output is 6 minus 3 minus 6 3. See here, 6 minus 3 minus 6 3. So we got the same answer. So here also, right? So then, so we are plotting the graph. Okay, that one is very important. So here plotting the first sequence, second sequence and output. Okay, so here figure 1. So here in the single plot, right, this is a figure 1. Okay, this is one single plot. In the single plot we are placing 3 different plots. Okay, so it is possible by using Matlab. Okay, so we'll see how to plot the 3 plots within the single figure. Okay, so figure 1, this is figure 1. In this we are dividing as a using a subplot, right? This is it. We are placing 3 figures. Okay, this is row into column, 1 by 1 row into column, right? In the first row, in the first column, we are placing this figure, right? So AX, this is the x-axis. We are dividing the x-axis, right? This one is, what is that? This one here, 0, 0 0.51, 1.52, 2.53, right? So by using this syntax 0, we are starting from 0. This is a step 1 step. Okay, this is a maximum length, right? Length of x minus 1. If it is 4 means 4 minus 1 3, because we are starting from the 0 value. It varies between 0 1 2 3, right? So stem of ax comma x, ax is, so it will display these values, right? 0 1 2 3, right? In the x, so it display whatever we have given in the sequence, 0 1 0 minus 1. Shall we see that? See here, 0 1 2 3. So we have given 0 1 0 minus 1, 0 1 0 minus 1. That's all. This is our first plot, subplot of the sequence x of n. Similarly, this is the sequence x of n. We have this sequence, this syntax is very important. Okay, so if we are using this stem means it will display in the discrete format. It will display in the discrete format. Otherwise, it will display in the continuous format. I will show you. Just I will change this. Okay, just I will show how it will be in the plot. If it is not stem, if we are using plot means it will display in the continuous format. See the output. What is the first sequence? 0 1 0 minus 1, right? 0 1 0 minus 1. Next one is 1 2 4 8. See, this is a continuous format. This is the continuous. In order to display in continuous, we have to use plot function. This is the plot function. Okay, so I don't want, I need in the stem, right? So in the discrete format, so I can run. So 0 1 0 minus 1 1 2 4 8. Okay, see, it is a discrete format. Okay, so I need to display this plot, right? So this is the second plot. What is that syntax? We have to use subplot. So we are displaying three figures. So we are here, we have to use three numbers. This is first row, right? This is a second column, right? This is, sorry, this is a first row, second row, third row, right? So I need to display in the second row, right? How it is taking row into column? It is taking in the row into column wise, right? So row, first row, this is a second column, then it should have to display here. So like I will discuss this one later. Okay, so usually it will display in the row into column wise. So I don't know how it is taking now, right? Till this is a row, this is a row, this is a column, right? I will tell you later. Just it will display in the second place. This one it will display in the third place. Okay, so the remaining things will be same. Okay, this is X label and Y label. X label means, so it will display whatever we are, this is a function. S label function means it will whatever we are written in the single quote, it will display in the X axis. It will display in the X here, sample, right? So whatever we are using, this is Y label. So Y label amplitude, it will display in the Y axis. This is the title, first input sequence. See, this is the title of the first plot, first input sequence. This second input sequence. This is circular convolution sequence. So according to the figure, so this may be column, first column, this is second row. Okay, this is a first column, this is a third row. Okay, but I will clear in the next video in detail. Okay, for a time being, just understand this concept. So we have displayed first sequence, second sequence. This is the output result, circular convolution of x of n and h of n, right? So these are the same things, whatever we have written, just it will change here. So we have to use output result ay, right? And this is the length y. Okay, so result y, right? This is result y, and this is a1 means this is ay. Okay, this is x-axis, this is y-axis. um, thank you very much. I think you have understand this program, right? Circular convolution using FFT and IFT. So we have written this program in the Matlab. Okay, we will see in the next video. Thank you very much. Have a great day.